Right, so thank you very much. I'm honored to be here. Sage wrote me an email a couple of weeks ago saying, would you like to give a talk on the academic use of Ceph? And I said yes, and I thought I would be off in a corner somewhere talking to the academics, the 10 people that show up. So being here on stage was a bit of a surprise, but see what we can do about that. I have to start off with a disclaimer, of course. Switch and Ceph, we go a long way back, and we love Ceph. Ceph has been really good to us. It has been a wonderful tool. So you should take everything I say with a grain of this love salt. But we're here for science, so let's have some real hearts beating. And I want to go from hearts to something else. And what you see up here is a slice of a mouse brain. Now, you might wonder, why would you have a mouse brain on stage here? But this is for science. So what we're looking at is the image of a laser beam shaping imaging microscope. A mouse brain contains about 0.5 terabytes of data. One of these microscopes can image 3 mouse brains per week, which I would guess gives you around 120 mouse brains per year, which is 60 terabyte of brain data that needs to be made accessible and stored for research and for future. And this is where we come to storage. We also come to scientists, and this is probably the weirdest office sign I've ever seen. That was at the lab, at the imaging lab last week. So what were they thinking, right? Switch is a national research and education network, as we call it, an NREN. NRENs exist to provide services to academic infrastructures, and there is one in every country. We happen to be the Swiss one. We are bound to serve the academia, the public. We have a number of core competencies that I'm not going to go through in detail, but we are a foundation. We're a public foundation. We're not a for-profit company. We're not a government organization. We're something weird in between, and our funding deed was to provide services of telecomputing for teaching and research. And that was done in 1987. I wonder what kind of modern telecomputing equipment they had back then, but we have quite a few interesting things now. Our customers are basically the universities and their related institutions, research institutions. We serve all of them equally. We have other institutions that are loosely connected to research, like university hospitals, for example. And we also have a couple of commercial customers. One of them is the Swiss government, because we are, by an happy accident, we are the registry of the CH top-level domain. And that is a story for another day. It happened, it's something with a professor that registered .ch at the ICANN many, many years ago, and then we're sitting with the top-level domain for Switzerland and wondered what he should do with it, so he gave it to us. We provide a lot of services. The core service, the one that started it all, is internet. We operate 2,500 kilometers of fiber in Switzerland. We own the optical equipment, and we have 100 gigabit per second backbone across Switzerland, and most of our universities, or all of our universities, are connected to it. Only very few have the 100 gigabit access. Something that we provide also is access to CERN and the supercomputing center in Lugano. We are part of the academic community, so we're not coming in as a vendor trying to sell stuff to the universities. We see ourselves as partners, and luckily the universities also see us as their partners. So we have discussions on a whole different level than just trying, here's some stuff, give us the money, and you'll be good. We also work internationally in tons of different organizations across Europe and the world. My team, infrastructure and data, as you can see, is a member, part of the OpenStack thing, and there's a space down on the right, and I hear from our legal team that we are ready to sign the Ceph Foundation agreement, and we'll be part of the Ceph Foundation as of today if things go well. And we're really happy about that. But anyway, I'm going to talk to you about where we come from and what we have been doing in particular with Ceph in the last couple of years. Many years ago, when computers were big, people came and said we should have small computers and a lot of them, and thus was born the grid for academic use. Some of you may remember the thousands of machines that were doing batch jobs, and Switch was active in the European Grid Initiative. However, that started to fade away in the early 10s when this newfangled thing from a internet bookseller started to become more and more interesting to people. So we started to look at ways how we could provide services on a more self-served, cloud-based model. And one of my colleagues proposed that Switch should start investing in cloud. And said and done, we started in 2012 with building a first small cluster consisting of 8 machines, see if we could get this up and running with some open source software that we found on the internet. Basically, we started with OpenStack, which was a guess at that time. There were other cloud providers, cloud orchestration providers in the market. We choose OpenStack. And for storage, actually, like my colleagues from CERN said yesterday, there was only one choice, and it was Ceph. And so we started with that. What you see up here is a slide from a presentation in 2013 that we gave, which describes our very first infrastructure, and boy, were we proud of it. 64 servers across 2 data centers, 32 compute nodes for all of 448 cores, and 32 storage nodes divided among 2 Ceph clusters with all of 1,200 terabyte raw capacity. And we thought, we've got a setup here. We didn't, but you learn that afterwards. We are hosted in universities. The data centers we operate are in the cellars, in the basements of these 2 universities, one in Zurich, in the German-speaking part of the country, one in Lausanne, in the French-speaking part of the country. That also takes care of politics, because you have both regions equally pleased, and it also is great for geographic diversity in case of disaster recovery things. We've been growing over the years. We've been continuously upgrading our clusters. These are the current numbers. I think we have around 400 servers, I'm not sure. We have 3,700 and some cores, physical cores. As of last week, we cannot count the hyper-threaded cores anymore because of Intel's bug of the year. And we have a couple of Ceph clusters. Currently, we have around 10 petabyte of raw capacity on spinning Rust disks, and we're slowly starting to build out our NVMe disks pools, and we plan to migrate our virtual machine workloads to NVMEs at some point in the future. Research is also not only about data, but also about compute. So we have heard requests from our customers for graphical processing units, GPUs for machine learning, and so on. So we have a few of them. And the most surprising thing to me when I put together these numbers, we started with 2 switches. Now we have 26 switches. They proliferate much more than compute hardware. We still have our dual 10 gig uplinks, but we're upgrading them to 100 gigabit uplinks in the near future. And the last thing here, what we also provide is layer 2 tunnels into campus networks that allows virtual machines that run on our cloud infrastructure to be part of a campus network, which is something that the university or the IT departments at the universities like quite a lot. Right, so back to Ceph. We dug out emails and found out that we actually started with Bobtail. Back then there's an email to Sage asking for help on one of our very early clusters. And we've gone through all of these releases. We are currently on Luminous in production, and all our test and staging clusters have been upgraded to Nautilus. We're still debating if we should upgrade to production this week at KubeCon or next week. We'll see, unless we hear word that we shouldn't go productive. But we are very confident that this actually works the way it should do, because Ceph has been extremely stable for us. And yesterday's talk by Vito and Piotr about performance also stressed that it's more important to have reliable data than performance. At least for research data, that is clearly the case. So the clusters that we are operating today, the two productive clusters, have the same data. They are 6 years old. It's the same clusters. They have been upgraded over the years, and we have never lost data on them. We had a few small problems, but we never lost data. We never lost access to that. So that's one of the reasons why we love this infrastructure. We've had a couple of problems, and I'd like to share a couple of war stories to make this less academic. I think there are three types of problems you can have with the Ceph cluster. One is easy problems. You have a disk die or a server dies. Everybody knows what happens. It just works. And fine. It's a bit more interesting if a switch dies, where half of your storage cluster is attached to. We had that happen with our old switches that went into packet storm mode and basically stopped responding to everything. So half of our cluster went down, half of our Ceph cluster lost connectivity. And the result of that is it just works as soon as somebody got out to the data center and kicked the switch, because we didn't have remote hands at that point. But easy stuff. That is easy peasy things. There are medium problems, maybe. We had Mons crashing back in the early days. I think it was Mons. And it just worked because we got Sage on IRC, and he helped us debug and recompile the software at night, at our night, at his day. So thank you, Sage. Wonderful support. There's also other things. I remember a case in 3 years ago when we had a PG unfound, which Google was very unhelpful with, and the Ceph documentation was very unhelpful with. Well, it turns out it just works. If you know how to ask the right people, which turned out to be the CERN guys, that gave us the secret command line option to get the Ceph to ignore that unfound disk. And I wanted to give it to you, but unfortunately, it's stuck behind the Slack ransomware thing, and I couldn't find out what it was that the CERN engineer told us 3 years ago. But I guess you could do a grep on the Ceph code base and search for command line options with force in them. And then there are hard problems. And I think the hardest problem we ever encountered was the clicker. No. Last year we had random performance problems on random VMs. And they just started to behave completely erratically, slow requests, and they ground to a halt. And it was random. We couldn't predict when it would happen or to whom it would happen. Well, to whom it was clear because it was those VMs that had the highest I/O load, which turned out to be the VMs of our best paying customers, which was a bit of a problem. And the usual, well, reboot the VM and see if it goes away. That helped for a while, and then it came back. So nothing seemed to work. The problem got increased by me being on vacation, which meant that this got management attention. And management didn't quite understand how a distributed storage system works, so they sent off the team chasing various rabbit holes. One of them was we should blame the running BlueStore migration, because if you have problems with the storage, BlueStore must be the culprit. That didn't help either, so we thought we'd ask the nice people at CERN because that helped last time. Thank you for trying to help. It didn't. We didn't find it out. It took us around 2 weeks to get to a state where we could reproduce this behavior synthetically. So it was very, very difficult to diagnose. And what we then found is we shouldn't look at the storage cluster, but at the network. And after a while, our engineers discovered that after a while, TCP connections got dropped to 512 byte fragments every 200 milliseconds, and they would never recover. Install a new kernel because there was clearly a bug in the TCP stack of the kernel, and it started working again. So you never learn. You never stop learning. That was quite an experience, and luckily we could pass on that knowledge to colleagues at another university a week later that ran into the same kind of problems. So Ceph is very stable, and Ceph is also very versatile. You know, the Swiss soldiers' pocket instrument here of choice. Ceph sometimes feels a bit like it does everything. It has RADOS, it has RBD, and so on and so forth. However, at some points in life, there might be times where a certain tool, like a real hammer or a real saw or a real knife, are better. And while we use Ceph for a lot of things, we also have started to look at other storage systems. We don't feel like this is cheating on Ceph. We more feel this is a polyamorous relationship that we have. And we try to use the best tools for the best job. Right. So, does anybody know what this is? It's an engine. It's the Babbage difference engine, or a model of it. So we provide compute, and we provide storage to our customers. And when we built SWITCHengines, we always had the feeling that storage would be the thing that would be more interesting to people. That was a hunch we built on. We built this thing a bit on this field of dreams, saying build it and they will come. We built it and they didn't come immediately. And we thought, why is that? Why are people not rushing to put all their data onto our wonderful Ceph clusters? And I guess one of the problems is we looked at our SWITCHengines shiny things, shiny red fire truck or milk truck or whatever from this perspective, and people actually looked at it and saw that it wasn't that big as we thought it was. And we hadn't proven ourselves yet to be able to provide all of this capacity to them, again, stability and availability. So what we did is we ate our own dog food. We have another product called SWITCHdrive, which is a sync and share service for academia that is built on another open source tool, OwnCloud. We put that on SWITCHengines, put that in production before we went into production with SWITCHengines itself, and put it out to the universities. And that has been quite a success. This is the last 4 years of storage. We started out with 0, obviously, but we don't have graphs going all the way back. When this graph started, we had 26 terabyte of data on SWITCHdrive, and now we're at 240 terabyte of user data. We're serving 30,000 users of Ceph, of not the most or not the best infrastructure. We run virtualized NFS servers with virtualized RBD volumes, and there are, I don't know, 50 or 60 RBD volumes in that cluster of things. They're all linked with symlinks and various weird contraptions, but it works. And we lost data once, but that wasn't Ceph's fault, but OwnCloud's fault, due to some weird things. The other thing that that happened by accident was that we have a product called SWITCHtube, which you my guess is a video serving platform for academia. The tool that they're using, they had an S3 interface, and the team discovered that we also had an S3 capable storage bucket. So they put their video data onto us, and that caused the first denial of service attack when one of the universities started to run videos on all their digital signage signs in nonstop for over and over and over. But right now we have something like 45 terabyte of video data that we're streaming directly from the Rados clusters. So the uptake is coming, data is coming. There's a bunch of our users, and I want to point out one of them in particular. It is the Data Science, Swiss Data Science Center. The Swiss Data Science Center is a project funding tool. It will fund projects in data science. And one of the projects that it's funding is the ACE data, the Antarctic Circumnavigation Expedition, which is delivering added value to Antarctica. That was an expedition that took place, I think, in 2016-17, in which a Russian icebreaker manned with 120 scientists circumvented Antarctica and collected data points, everything from measurements of the water quality to I think they took thousands of photographs of snowflakes as well. And this data is now being processed and made available for research. And you might say, well, what's the point of that? The thing is, these expeditions, they happen roughly every 30 years. So the data that this expedition has collected must be made available to researchers over the next 30 years so that they can do whatever research that they're doing. And we are providing part of the infrastructure to make that research data available. I think that is a wonderful purpose to have as an organization, is to be part of this scientific fabric, if you will. So where do we go from here? Well, we go for science, for research, and for education, and Ceph will be there with us along the way. Thank you very much.